So it is given that this function models the trajectory of a long jumper, where x is the horizontal distance from the initial point and h is the height off of the ground. Now, a couple things to keep track of. So notice that this function is a quadratic and that it has negative orientation. So we have something like this here going on, where it's a parabola that's upside down. And this is going to be the jumper's maximum point, maximum height. Now notice that this x coordinate is when the jumper is at their highest point. So x represents how far away they are from their initial point, and h represents the height off of the ground. Now, this is the vertex, remember that notation, that vocab? The vertex is the highest point, in this case of an upside down parabola. Now, how do I find the coordinates of the vertex? Well, the vertex is a point, and every point has coordinates, an x and a y. So here, to find the x coordinate of the vertex, you'd have to go negative b over 2a, where this is a, this number is b, and plus 0, 0 is c. So for part A of this exercise, why don't we find the horizontal distance from the launch point where the maximum height occurs? In other words, evaluate negative b over 2a. So I need negative, and then the value of b over 2 times the value of a. And if you knock that out real quick, it'll be something like this. So type all that into your devices, 2 times, type all of that in. It should be a positive number because we're talking about, in this case, a positive distance. As a decimal, if we round 2 decimal places, it should be about 3.96. Are we using feet, meters? What are we using? It says, I don't think it says. Yeah, it says meters. So this would be the result. So what this is saying is the jumper, they jump off the platform, whatever, their highest point is reached about 4 meters away from where they jumped from. There we are, that's part A. And then part B, what is the maximum height that the jumper achieved? So that's the y coordinate. You see, the x coordinate tells you when or where the max height happens. The y coordinate is the actual height itself. So what we have to do is we have to take this number and plug it in here. So we have to evaluate h at 3.96. And that would be about, so what I'm gonna do here on the device is take 3.96 and plug it into the original problem. So I got about 0.72 meters. And that's kind of weird because 0.72 meters, that's like 2 feet off of the ground. So that's kind of weird, but this is a long jumper. A long jumper doesn't really care about how high they jump. I think they care about how far away they jump. But anyways, that's what I got for part B. And then for part C, they wanted to know what is the length of her jump. So for part C, so watch, let's say that's the ground. The length of the jump would be all of this here. So the length of the jump occurs when the jumper is done jumping. You see, they jump off the ground, they hit the high point, then they hit the ground, boom. So I want to know what the overall length was. So the height has to equal 0, because when the height is 0, you're either before jump or at the conclusion of your jump. So what I'm gonna do is I'm gonna plug in 0 into the equation. So that'll be 0 equals negative 0.046x squared. And then we have to solve this equation. I would use the quadratic formula, and that is an option, but you don't have to, because there's only 2 terms and they both have x's. So you can actually factor out x. And if you factor out x, here is what you would have left over. You'd have left a product of 2 objects. And since the product is 0, by the 0 product property, you can let each object equal 0 and solve. So because this equation here says x equals 0, that means that at the beginning of the experiment, the jumper was on the ground, and that makes sense. But now let's solve this equation. Subtract this and then divide by that. So it essentially becomes this here, that number essentially divided by that number. And that says about, if you round to 2 decimal places, about 7.91 meters away. So in total, the jumper landed about 7.91 meters away. Now, notice that it's not a coincidence that if you had taken your answer from part A and multiplied it by 2, that you would have gotten something awfully close to this number here. So that's not a coincidence. It's just how the symmetry of parabolas work. But anyways, here are the results.